Good evening, dear students. Now I want to discuss enthalpy of neutralization. What is the definition? When 1 gram equivalent strong acid reacts with 1 gram equivalent strong base, then how much amount of heat energy released? Minus 13.7 kilocalorie or minus 57.1 kilojoule energy released for particularly 1 mole water. Clear? For 1 mole water, how much amount of energy released? Minus 13.7 kilocalorie or minus 57.1 kilojoule energy released. Here negative sign indicates exothermic reaction. Now, here HCl, that is strong acid. HBl, KOH, that is strong base. When HCl reacts with KOH, KCl plus water formed. Now, here we can write HCl aqueous. HCl aqueous. How it dissociated? H plus aqueous plus Cl minus aqueous plus KOH. How can we write? K plus aqueous plus OH minus aqueous giving rise to KCl aqueous. How it dissociated? K plus aqueous plus Cl minus aqueous plus water ionization negligible, H2O liquid. Now here Cl minus you can cancel, Cl minus, and K plus cancelled. Here cancelled ions are called spectator ions. Here cancelled ions are called spectator ions. Cancelled ions are called spectator ions. Then resulting net equation H plus aqueous plus OH minus aqueous giving rise to H2O liquid. So simply this equation is called enthalpy of neutralization. 1 gram equivalent strong acid react with 1 gram equivalent strong base, then for 1 mole water, how much energy released? 13.7 kilocalorie or 57.1 kilojoule energy released. Clear? Yes, here remember for 1 mole water, this much of energy released. Now, by using one problem, by solving one problem, we will get more clarity. Now, please concentrate on this problem. When 500 ml of 0.5 molar HCl reacts with 500 ml of 0.1 molar KOH. Calculate the enthalpy of neutralization of reaction. So now, first for HCl, we have to calculate moles. Here molarity 0.5 molar given, volume 500 ml given. You know what is the what is the molarity formula? Molarity equal to moles into 1000 by volume in milliliter. Now from this moles of HCl equal to what is the formula? Molarity into volume in milliliter by 1000. From this you can calculate molarity 0.5 and volume here 500 by 1000. Then what is the value? 0.5 into here 0.5 means 0.25 mole. Clear everyone? Similarly for KOH, you can calculate similarly for KOH. KOH molarity how much given? 0.1 molar. KOH volume how much given? Here 500 ml. Then moles of KOH is equal to molarity into volume in milliliter by 1000. Now molarity 0.1, volume 500 by 1000. Then what is the value? 0.05 mole. Understood or not? Now here observe once. How many moles of HCl react with how many moles of KOH? 0.25 moles HCl react with 0.05 mole KOH. Now once write balanced equation. HCl plus KOH giving rise to KCl plus water. HCl 0.25 mole. KOH 0.05 mole. Now, what is the limiting reactant formula? Calculated moles by stoichiometric coefficient. Calculated moles by stoichiometric coefficient. Then 0.25 by 1, 0.25. 0.05 by 1, 0.05, which is a lower amount that is completely consumed in the reaction first. Which is a lower amount that is completely consumed in the reaction first. So 0.25, 0.05, which is lower, 0.05. This is the low amount. So it is limiting reactant. Which is a limiting reactant? Remember, KOH is limiting reactant. Now, from KOH you have to calculate amount of water because here KOH is limiting reactant. Understood or not? Always the amount of water can be calculated by using limiting reactant. Now from balanced equation, 1 mole KOH releases 1 mole water. 1 mole KOH releases 1 mole water. Now 0.05 mole KOH releases how much amount of water? Yes, same amount of water. How much? 0.05 mole water only released. Understood or not? Now, how can we calculate? So, for 1 mole water, 13.7. For 0.05 mole water, how much? So, enthalpy of neutralization is equal to here minus 13.7 kilocalorie per mole. Okay, so how much amount of water here generated? 0.05 mole water. For 0.05 mole water, how much energy released? 13.7. Then here what is the answer? What is the answer? So minus 13.7 into 0.05. What is the value? Minus 0.685 kilocalorie. Understood or not? In calorie 685 calorie is the right answer. Understood? This much of energy released. For 1 mole water 13.7. For 0.05 mole water 0.05 into 13.7. So how much energy released? 685 calorie energy released. Understood? For releasing here using negative sign, that is exothermic process. Exothermic process we are using negative sign. I hope everyone understood this problem. Yes. Moving to next problem. When 5 moles of KOH reacts with 2 moles of sulfuric acid, then determine enthalpy of neutralization of reaction. Understood? So here 5 moles KOH react with 2 moles sulfuric acid. Then we have to calculate enthalpy of neutralization. So now first write balanced equation. So 2 mole KOH reacts with 1 mole sulfuric acid to form here K2SO4 plus how many moles water released? 2 mole water released. 2 mole water released. Understood? This is balanced equation. Now limiting reactant. Of course here moles directly given. So KOH moles 5 mole. Sulfuric acid mole in the question 2 mole given. Okay, clear? 5 mole, 2 mole. So 5 by stoichiometric coefficient here 2. Here stoichiometric coefficient 1. Then 5 by 2 means 2.5. 2 by 1 means that is 2. So which is lower value? Here 2 is lower value. That's why this is limiting reactant. Understood or not? Always we have to calculate amount of water by using limiting reactant. Now by using balanced chemical equation, 1 mole sulfuric acid releases 2 mole water. Understood? 1 mole sulfuric acid releases 2 mole water. Then for 2 mole, okay, for 2 mole how much amount of energy How much amount of water released? How much amount of water released? 4 mole water released. Understood? 4 mole water released. So now enthalpy of neutralization, okay, that is equal to now 4 mole. Clear? For 1 mole, how much amount of energy released? 13.7 kilocalorie. For 1 mole water, how much energy released? This much of energy. Now, what is the answer? Here, minus 54.8 kilocalorie. So, this much of energy released. Understood? This much of energy released. I hope everyone understood. Yes. Now, moving to next problem. In which of the following reaction maximum energy released? So this is important model problem. In which of the following reaction maximum energy released? HF plus KOH giving rise to K plus water, HCl plus KOH giving rise to KCl plus water, HBr plus KOH giving rise to KBr plus water, Hi plus KOH giving rise to Ki plus water. In which reaction maximum energy released? Then here we are expecting which option is right? Fourth option. But that is wrong. Here which option is right? Option 1 is right. Which is right answer? Option 1 is right. Usually, atom size increases, bond length increases. Atom size increases, then bond length increases. Okay, so bond length increases, understood? Bond length increases, then bond dissociation energy decreases. Therefore, that releases H plus quickly. So acidic nature increases. Here, which is readily give H plus hydrogen iodide. That's why we are expecting here HI is strongest acid. No doubt at all, HI is strongest acid. That's why Hi plus KOH giving rise to Ki plus water. In this reaction, more amount of neutralization energy released. No doubt at all, that is right. But here question maximum energy, not enthalpy of neutralization, not neutralization energy. Here total energy, total maximum energy released in which reaction. So here option 1 is right answer. Reason generally ion dipole interactions. Here which is right answer? Ion dipole interactions. Here generally HF plus KOH giving rise to KF plus water. Here generally KF, this is aqueous, this is liquid. In this reaction, HF is no doubt weak acid. This is the strong base. That's why resulting energy, neutralization energy, less energy only decreased. But hydration enthalpy, more hydration enthalpy released here. Okay, which is released here? Hydration enthalpy more released. That's why total energy, neutralization plus hydration enthalpy, that resulting energy is greater. That's why here option 1 is right answer. Here actually K plus, that K plus is stabilized by greater number of water molecules. Okay, that K plus ion is stabilized by greater number of water molecules. So here stabilization gaining by surrounding water molecules. So stabilization gaining means heat energy released. That released energy is called hydration enthalpy. That released energy is called hydration enthalpy. Understood or not? Now, like hydrogen bonding here. Which bonding? Hydrogen bonding. Here we can write like which bonding? Hydrogen bonding. So clear? Hydrogen bonding. So now here K plus ion, F minus ion, they are stabilized by surrounding number of water molecules, greater number of water molecules. So more here, more hydration enthalpy released, more hydration enthalpy released during this reaction. So therefore, in which particular reaction, okay, in which reaction, released energy, okay, released energy means here two energies, sum of two energies. Neutralization energy, of course, it is less than 57.1 or 13.7 kilocalorie, but that neutralization energy plus hydration enthalpy also released. Okay, this sum of energies definitely it is maximum, more energy released. That's why that released energy is greater. Released energy is greater as compared to remaining reactions. That's why here option 1 is right answer. Understood? But Br minus, Cl minus, I minus, they are not effectively involved in ion dipole interactions. But here F minus ion, this is effectively involved in ion dipole interactions, that is hydrogen bonding. That's why in this reaction maximum energy released. Understood? So this is the exception case. This is the exception case. But here what we are expecting, fourth option is right answer. Hi plus KOH, strong acid, strong base. But here unfortunately, which option is right answer? First option is right answer. Which option is right answer? First option is right answer. This is the exception case. Clear? I hope everyone understood this concept. Okay. Thank you. Thank you so much.